All right, what's up, everybody? It's Robert Cooper again for data visualization. We are going to talk about animated plots this time. Um, Pretty cool stuff going on here. We're going to do it with the gganimate package, um, which is part of the broader tidyverse. It's a separate package that you can call. Um, you can actually also do these animations with another package called Magic, but that's a good backup just in case gganimate's not working for some reason. Um, gganimate's gone through a bunch of recent updates and it's working really well now, but I suppose you never know. So Magic is a good backup, and I might do a separate video on that. Okay, so let's talk about gganimate and animating plots. So when you view the actual plot as it's animating, you're going to look at it in the viewer window, not in the plotting window, just so you know. So normally when you're making a plot, you look in the plots window, right? Well, this time you're going to be looking in the viewer window. The most important thing for an animation in gganimate is the transition. Usually, the way it works is it produces basically a slide deck and then does it like a flip book in a GIF, right? So the natural place for these to go is to HTML. That's where it animates really well. So like if you save your animated GIF at the end and it's on your computer and it's just as a GIF, it's going to look like a slide deck, like a slideshow. But then you put it in HTML and it will animate. Okay, so transitions. Transitions are the most important thing. You'll think about what kind of variable you want to transition on. Usually it's something like the categories of a variable or maybe time or something like that. So you're going to write code like you're writing a normal plot, then you're just going to add some lines, add some layers for the animation. So we're going to start with transition, and we're going to do transition states, which is by definition for a categorical variable, and it calculates some smooth transitions in between. We'll also talk a little bit about transition reveal or time. These are related. Well, this is actually dimension based, but often you would use this with time, so I should say dimension based here. Let's see, and then we have things called easings. So there's another layer called an easing that you can add that will make the transition between states, how fast, how slow, and what kind of fast and slow it executes. Sort of the velocity or the speed, uh, and you've got some weird options where you can speed it up in the middle, but slow it down at the beginning and the end, and things like that. So there are lots of different options there for easings. Enters and exits are available for how you let the data appear first on the plotting environment and how you make them exit the plotting environment. So you can do things like fade them in or shrink them out, those kinds of things. You can actually do more than one enter to do like a combination effect. Same with the exit. You can also do enter and exit manual, so you can like kind of make your own. You have shadow layers, things like a shadow wake, where you can sort of have trailing values produce almost like a kind of a ghostly trail as you go through a transition. And the most important thing, one of the most important things to think about is group aesthetics, because like whatever aesthetic you use to tie to a group is what the transition or the animation is ultimately going to work on. Now you have to be careful, because if you choose a group observation that is grouped by different categories, so like let's say we were working with the MT cars and we were talking about different cylinders, you wouldn't want the transition to end up looking like a scatter plot with 4-cylinder cars, then transitioning smoothly over to the 6-cylinder cars and then to the 8-cylinder cars, because that is a visual implication that the 4-cylinder cars are morphing into the 6-cylinder cars, so you're actually making unlike observations alike. You're sort of implicitly saying that this transforms into this, transforms into that, and you don't really want to do that. So that's sort of it's visually appealing, but it's also kind of dishonest. So what you would rather do, if you were going to plot on the group variable cylinders for car in this case, which we'll do as an example, you want the transitions to be clean, where the 4-cylinder cars sort of appear and disappear, followed by the 6-cylinder appear, disappear, and then the 8-cylinder appear, disappear. That way there's no connection between the 4, 6, and 8. That's a little bit more of an honest animation, you might say. So we're going to do one. And I'm just going to talk through some examples. So we're going to start, I'm going to go ahead and start running this. But up to here, all the code is what you would already know if you had been watching any of the videos or taking the course. Then we have the transition states, and I made this factor, cylinder factor, because it starts as a numeric for no good reason. So we're changing it to a factor like it's supposed to be, so it's a categorical variable. And then these arguments, transition length and state length, just sort of talk about how long the animation is going to stay where it is and how long it's going to transition. And then I talked about the easings. This is ease.aes is the easing. And this is one of the options, cubic in, out. And then I'm going to use, I'm actually going to just do one right now. Enter fade, exit shrink. So I'm going to fade in, shrink out, and then let's see how it looks. So you see down here, there's a rendering bar, and this lets you know how long it's taking. It should be about 30 more seconds, and then we'll see it produce the slides, and then it'll pop up in the viewer window. So I'm gonna expand the viewer window for just a second so you can see it better. And some of these animations, depending on how complicated the animation is, it could take a long time. So, and by that I mean between 3 and 5 minutes, or maybe something like that. Okay, this is a completely unadorned, and the window is not large enough to show all of it. So you can see it's got basic, this is unadorned, we need to fix labels, those kinds of things. But you can see how the animation is coming through. 4 cylinders, 6 cylinders, and 8 cylinders. Now we don't have a title right now, and you can actually animate the title so that it would say 4 when it's 4, 6 when it's 6, 8 when it's 8, those kinds of things. But this is the basics of making an animation based on a categorical variable. All right, so that's unadorned. That is with this information here. Let's see, I'm not going to use, there's no real reason to use shadow when you're going from one to the next like that. Let's add a drift. So I'm going to kill that plot in the viewer, and I'm going to run it again. And I added a new enter, so a second enter. It's called enter drift. And there's a modification for x, and it says -1. That means it should be coming in from the left. And I will wait just a second and let it render again. But you have lots of interesting, fun options with this, and it works pretty well and pretty seamlessly, at least currently. The current iteration of it works really well. So you can see now it's transitioning in from the left. So it's fading in from the left and then shrinking as it disappears. That's the combination that I put together there. So we would want to fix labels and maybe put up a label at top, things like that. Okay, so that's number one. Let's use transition reveal this time and do time. I'm going to do a plot. What I'm going to do, I'm going to explain it real fast. A plot of Finland from the World Income Inequality Database that my students and participants are familiar with. It's going to be up to here. It's just some work with the data because there are multiple observations per country per year in some cases, so you want to average over them so that you have Finland values by year. Finland after 1940 to get the most number of observations per year. And then we start adding some stuff. And the stuff that we add is the shadow wake, which is new, and the view follow, which I'm actually going to do them separately because the view follow is kind of funky. You'll see what I'm talking about. So instead of transition states this time, we're doing transition reveal. And the transition reveal works along a dimension, and in this case, and you have to have this a long argument, and in this case, we're doing it by year. Okay, this is kind of similar to time. Okay, I'm saving it as an object now, and then, so this is just a slight variation on the previous animation, where you save it as an object, and then you actually animate that object with a separate animate verb function. Okay. But then what you get to do is you get to specify the number of frames you make, and this can help make it smoother, slow down the animation, those kinds of things. You could do all sorts of stuff with this. All right. I'm adding a wake. I'm adding a shadow wake, and I've done something else as well. You see I have two geoms here. I have path, which is kind of like line, and then I have point. So what it's going to do is it's going to produce a line, but it's also going to have the leading point be a point as it's going through. That's what it's going to end up looking like. So let's execute and execute the animation. Now it says 2 minutes. Now it says 1 minute. So it's going to take a little while to render. So I'm going to talk a little bit more about the options. Like, I'm only doing this for one country, but it could very easily be multiple countries going on at the same time. In fact, some of my assignment problems have like full regions, you know, like Southern Europe or all countries in Northern Europe or, you know, parts of South America or something like that. And I have them animated across time. Usually across time in that case. And that's a natural choice to do it across time for transition time or transition reveal especially. Let's see, once it starts to render, I'm gonna expand the window a little bit. Now in the viewer it looks a little bit fuzzy, but again, the place where GIFs are supposed to be animated is in HTML. This is not in HTML. So this is kind of cool, right? So you've got a leading point and a path following it. And that represents the movement of Finland's income inequality as measured by the Gini index over time. And you can see we could have put a counter up here for the year, but we don't really need it because we have the x-axis and we have a label over here. That should be capitalized if these others are also going to be capitalized, but that's neither here nor there. So this is what you can imagine it in HTML. So like if you render a markdown document and you save it that way, it's going to look much cleaner and it's going to look crisp, right? It's just a little fuzzy because the viewer window is that way. Yeah, so that's 2 options for animating plots. There are plenty more, but I think that's enough for this particular video. All right, we'll see you on the flip side.